Physics Part 90. Because weight is given by the product of mass and the acceleration of free fall, the equality of the weights means that the masses are also equal. We have introduced the idea of weight by thinking about an object in free fall, but objects at rest also have weight. The gravitational attraction on a book is the same whether it is falling or whether it is resting on a table. The fact that the book is at rest tells us by Newton's first law that the resultant force acting on it is zero, so there must be another force acting on the book which exactly balances its weight. Here the table exerts an upward force on the book. This force is equal in magnitude to the weight but opposite in direction. It is a normal contact force, contact because it occurs due to the contact between the book and the table, and normal because it acts perpendicularly to the plane of contact. The weight and normal contact forces are shown. A book resting on the table forces on the book forces act same vertical time but are separated slightly for clarity. The book remains at the rest on the table because the weight of W of the book downwards is exactly balanced by normal contact force are exerted by the table on the book. The vector sum of these forces is zero, so the book is in equilibrium. A very common mistake is to state that by Newton's third law, W is equal to R, but these two forces are both acting on the book and cannot be related by third law. Third law forces always act on different bodies. To see the application of third law, think about a normal contact force R. This is an upward force exerted by the table. The reaction to this is downward force R exerted by the book. By Newton's third law, these forces are equal and opposite. This situation is illustrated in the figure. A book resting on the table, action and reaction forces acting at the point of contact. Having considered the action and reaction forces between book and table, we ought to think about the reaction force to the weight of the book regarded as an action force. Even when the book is not on the table, this is not so easy because there does not seem to be an obvious second force. But remember that the weight is due to the gravitational attraction of the earth on the book. If the earth attracts the book and the book also attracts the earth, this gravitational force of the book on earth is the reaction force. We can test whether the two forces do indeed act on different bodies. The action force, the weight of the book, acts on the book. The reaction force, the attraction of the earth to the book, acts on the earth. Thus, the condition that action and reaction forces should act on different bodies is satisfied. Problem solving. In dealing with the problems involving Newton's laws, start by drawing a general sketch of the situation. Then consider each body in your sketch. Show all the forces acting on that body, both known forces and unknown forces you may be trying to find. Here is a real help to try to draw arrows which represent the forces in approximately the correct direction and approximately to scale.